Hello everybody and welcome back. Today we are going to be going over Unit 4 lesson number 2, which is all about surface water. Now we just wrapped up our lesson on the hydrologic cycle, and we learned that during that process, the recycling of the water on the planet, after water falls to the earth as precipitation, most of the time in the form of rain, it can do one of two things. It can either go through infiltration, where it penetrates the ground, goes below ground and becomes groundwater, or it can become runoff and it can run into a surface source of water. Okay, so today we're going to talk about those surface sources of water, so water on the surface of the planet, and we're going to talk about some of the factors that will impact whether or not water will run off or kind of infiltrate into the ground. So let's go ahead and get started. These correspond with lesson 2 in your interactive notebook. So again, runoff is just the runoff from precipitation in the water cycle. So this could run into a stream, river, or lake. It could evaporate, or it could accumulate as puddles and eventually seep into the ground and become groundwater. There are different conditions that determine whether water will seep into the ground or become runoff. And these conditions are vegetation, which is plant life, the rate of precipitation, so how fast is it raining, soil composition, so what is the soil like, and also the slope. So with vegetation, the more grass or more vegetation there is, that means there'll be more water entering the ground. So the precipitation, the rain that falls on the vegetation, will allow the water to move more slowly from the plants to the ground. So it kind of almost acts as like a buffer. So instead of hitting the ground straight on, it hits the vegetation first and then slowly rolls off. And anytime that there's kind of this slowing down of the precipitation, it's going to be allowed to seep into the ground a little bit more. And then precipitation falling on barren land, so barren means that there's not really a lot of vegetation. It can cause clumping, which can close pores and create less water entering the ground. Okay, so more vegetation means it's more likely to become groundwater. Less vegetation, so less plants, means that it's more likely to become runoff. So the more vegetation, more infiltration, groundwater, less vegetation, less infiltration, surface water. The rate of precipitation will also affect whether water becomes runoff or not. So light precipitation, so a gentle drizzle or a gentle steady rain, again, that speed has a factor to it. So if it's lightly raining, that water is going to make its way to the ground a little bit more gently, and so it's going to be easier to just kind of soak into the ground to become groundwater. On the other hand, if it starts raining very, very heavily, those water droplets kind of like bounce off the surface of the earth and they will accumulate together to form runoff. So less precipitation or lighter precipitation equals groundwater, and heavy, intense precipitation means runoff and surface water. Soil composition also has a lot to do with whether or not liquids will become runoff or not. So soil with a high percentage of coarse particles, like sand, has relatively large pores between its particles that allow water to enter and pass through quickly. So if we remember from when we talked about soil, sand is the largest particle, the largest component of soil, and so it has a lot of pores. It's got a high porosity. So that means when it rains, the water will pass through it very quickly. On the other hand, a soil with high percentage of fine particles, like clay, clump together and the water cannot run through as quickly. So clay would be a particle that has a low porosity, a low permeability. So as the water hits the ground, it will not pass through the clay as easily as it could through the sand. Okay, so typically things like clay and smaller particle soils will contribute to runoff because the water is not going to be able to seep into the soil, whereas a soil that has a higher percentage of sand in it will allow the water to run through, and so you'll likely get more groundwater in those areas. So again, we do need to know the difference between porosity and permeability. Porosity is just the percent of rock that contains pore spaces. So if you have a highly porous soil, these are going to be soils with bigger particles and bigger pores between those particles, so things that typically are higher in sand. And then if you have a low porosity, you've got smaller and tighter packing particles, so things like clay that will pack tighter and not allow water through. So porosity is just how many pores, how big are the pores between the spaces. Permeability is the measure of ability to transmit fluids. It just means how fast or how well can water run through the substance. So if you have a highly permeable soil, the water is going to run through very quickly. If you have a low permeable soil, it's going to take that water a little bit longer, or sometimes a lot longer, to run through it. So again, a soil that has a highly porous and a high permeability would be a soil that has like a high composition of sand. And that's going to typically contribute or attribute to more groundwater because the water is going to be able to pass through. Okay. On the other hand, if you have a clay soil, which is smaller particles closer together, it will have a low porosity and a low permeability. So if it rains in an area with heavily clay soils, you're more likely to see surface runoff because that precipitation will not be allowed to pass through those clay soils because it has less of a permeability. Something else that is a contributing factor is going to be slope. So a steeper slope, you'll have a faster water flow when it rains. So this will be more of a contributor to surface water. And there's also a greater potential for erosion on steeper slopes as well. And then little water will seep into the ground before it runs off on steep slopes. So if we're looking at elevation or the slope of an area, we're more likely to get surface water in an area with a more intense slope because it will run down faster and the water really won't have the opportunity to sink into the ground and infiltrate into groundwater. So flat areas typically will have more of an opportunity for that rain to sink in and infiltrate and recharge the groundwater. Okay, so flat areas equals infiltration equals more groundwater. Highly sloped areas, like in the mountain areas, equals faster running water, which will lead to surface runoff, which will eventually accumulate into surface water. So we've talked about the different conditions that will contribute to either surface water or groundwater. And now we're going to take a look specifically at surface water, some examples of surface water. We'll go into groundwater tomorrow, but for now we're going to look at the examples of surface water on our planet. Okay, so some examples include streams, which are basically just smaller rivers, watersheds, floodplains, lakes and ponds, reservoirs, and watersheds, which include bogs, marshes, and swamps. So these are all examples of collection areas for water. They are surface water because they're on the surface of the earth, and anytime that there is runoff, the runoff is going to contribute to these surface waters. Now, your notes do not have specific examples of each of these because the activity we do that goes along with these notes are going to basically be pointing out examples and kind of explaining these a little bit more in depth. But for now, what we need to know is that all of these are surface water, which means all of them will be visible on the surface of the earth. And again, runoff is going to contribute to collections of this surface water. Okay, so that is the end of your surface water notes. Make sure that your interactive notebook is filled out for lesson 2, and we will dive a little bit deeper into these types of surface water when we do our activity that goes along with this lesson. If you have any questions, let me know, and if not, I will see you guys in the next video. Bye, guys.